Rockland Community College and our Rockland Astronomy Club's third in a series of lectures. It's really a great opportunity tonight for us. I'm extremely proud and excited to be able to introduce our guest lecturer tonight. And he comes to us with a lot of accolades and accomplishments. He is a on-camera meteorologist, a very successful and accurate meteorologist. I can say that because he keeps on telling us the weather forecast, and he's been pretty accurate, okay? But besides that, he's an accomplished scientist. He's published several articles in science publications relative to astronomy. I give a great, big round of welcome to our guest lecturer tonight, Joe Rao.
Thank you very much, everybody. Tonight we're going to be talking about an event, a very, very exciting event, certainly the celestial event of the year, maybe of the decade, and maybe one of the top celestial events of the 21st century, a total eclipse of the sun. How magnificent. How many people, just as a show of hands, how many people have not? Well, before I am done tonight, I'm going to convince all of you to go and see this upcoming event. It is such a magnificent and amazing sight to speak of. And we have three specific characters in this pas du trois, if you will, this dance among three. The Earth, of course, which is the planet we all lived on. And also, as you can see on the screen, we have the full moon. And the moon, of course, is very important. It was important to the ancients hundreds and thousands of years ago. The ancients who looked up at the sky felt that the moon was a goddess by the name of Selene. And yesterday, when they were trying to land that rocket on the surface of the moon, I was listening in on one of the commentators who said, well, they're going to make the orbiter go around the moon one more time because they're looking at the lunar geography. And I went, no, it's not lunar geography. Geo refers to the Earth. The topography of this planet is the geography. But when we refer to the topography or the landscape of the moon, scientists refer to it as selenography, as a tip of the hat to Selene, the goddess of, again, hundreds and thousands of years ago. So that was Selene. And of course, the most important object to all of us is the object we know as the sun, which gives us all its heat, all of us light, and without it, you and I would not be here. It was thought that in the same way that the moon had a goddess, Selene, the sun was controlled by a god by the name of Apollo. Apollo would drive the sun across the sky in his chariot. It would appear in the east in the early morning, climb high into the sky, reaching its highest point at midday, and then he would gallop down the western sky and disappear beyond the western horizon. And so we have Apollo and we have Selene. And one thing that the ancients knew, these two celestial bodies were very, very important, and we had to treat them with tender, loving care. If anything were to happen to either the sun or the moon, woe on us, because we needed those two bodies, one by day and one by night. We have stories from various cultures about events such as eclipses, and what I'm about to tell you now is the earliest known account of a solar eclipse. It goes back to China, way back, and in a way I'm happy. A couple of weeks ago we had the new moon and we had the Chinese New Year, and this is the year of the dragon. How appropriate, because this story deals in many ways with a dragon. The day was bright. The great sun hung motionless in the sky above the Yangtze Valley. The Chinese storyteller records what happened next. The dragon, Lung, restless with hunger, appeared, and before the eyes of the frightened people, Lung began to devour the sun. The day grew darker. The people raised a din, a chant of prayers. The dragon was startled. He desisted. The sun slipped from his jaws, and Lung vanished to await another chance. Our computers give us the date. It was October 22nd in the year 2137 BC. The rarity of what happened that day and what is to happen over North America on April the 8th of this year is explained by the fact that the moon does not orbit the Earth in the same plane as the Earth orbits the sun. If it did, the moon's shadow would pass across the Earth every month. Instead, the moon's orbit is tilted a little bit. So when the high side of its orbit is toward the sun, the moon's shadow passes above the Earth. Later in the year, when the Earth has revolved to a position on the other side of the Earth, on the other side of the sun, I should say, the low side of the moon's orbit is toward the sun, and the moon's shadow passes below the Earth. But when the Earth is midway between those two positions, the Earth, the sun, and the moon can line up properly. The orbit of the moon can bring it into a line between the sun and the Earth, and the result is what we're going to be seeing on April 8th, the shadow of the moon passing across the Earth. Now, as a postscript to that eclipse of 2137 BC, China had two court astronomers. The guy on the left is Hai, and the guy on the right was Ho. And unlike, we talk about astronomers today. Well, astronomers today can make predictions about where the sun and the moon and the planets are going to be. But 4,000 years ago, the court astronomers had only one job, and that was to look into the sky during the day and during the night. And if they saw anything that was unusual, they immediately would have to tell the Emperor of China and the people to look skyward, because the gods were trying to tell them something. There might have been a comet, a meteor shower, a strange gathering of the planets, or perhaps a guest star, a nova, as we call it today. That was Hai and Ho's job, to watch the sky day and night. Well, on the night before the eclipse, for whatever reason, Hai and Ho decided they'd have a private party, and they went to the drink. And before long, they became, and I'll say this very nicely, inebriated, and fell asleep. And so when all of this action was taking place, when the dragon was devouring the sun, Hai and Ho were nowhere to be found. They were asleep, and after the eclipse was over, the emperor called for them, and he said, "You guys really screwed up. You guys sinned a great sin. You were supposed to, it was your job to tell us when the dragon was eating the sun, to warn us, and where were you? Now, since you were dawdling, you are going to have to pay the ultimate price." And they did. They lost their heads. They were beheaded. That was what happened to Hai and Ho. Goodbye, Hai, goodbye, Ho. Heidi-ho. Anyway, the fact of the matter is that this is not an isolated case. We have stories in ancient history from all cultures of people who have looked up into the sky and saw the moon or the sun being devoured by some sort of invisible monster in the sky. Some cultures thought it was a pig or a goat, or in the case of eclipses of the moon, one particular culture in South America said a giant frog was eating the moon. But in any case, this goes down all through history, that man and women feared eclipses because they saw that that meant that they were going to lose perhaps the moon or the sun forever. There was an ancient limerick written by some anonymous person who said, "Sometimes I think of the sun and the moon as lovers who rarely meet, always chase, and almost always miss one another. But once in a while, they do catch up, and they kiss, and the world stares in awe of their eclipse." I suppose something like this, where Apollo and Selene got together, and as you can see below on the Earth, we mere mortals with our instruments, looking up at the sky and recording this incredible event that was taking place before our eyes. We, over time, recorded more than our fair share of eclipses. I'm talking about going back 4,000 years, and every time there was an eclipse, somehow someone recorded the circumstances of those eclipses. And over time, over hundreds and thousands of years, man started to learn something. These eclipses don't occur haphazardly. there is a specific cycle, there's a specific timetable as to how and when these eclipses take place. And these cycles would soon allow people who were able to calculate them to make predictions. And those who made those predictions were very, very powerful people indeed. We have, for example, Stonehenge, which I'm sure you've all seen at one time or another. Stonehenge, which is located in Salisbury, England, was built not all at once, but it was built in 6 stages between the years 3000 and 1500 BC during the transition from the Neolithic to the Bronze period. And astronomer Gerald Hawkins in England wrote 2 articles for the journal Nature in 1963 and 1964, in which he pointed out several new Stonehenge alignments to the sun and moon, proposing that the Aubrey holes. Now, take a look, this is Stonehenge as we know it today. But Stonehenge, when it was first built, all those years ago, probably appeared something like this. And you can see what we refer to as the Aubrey holes circling around Stonehenge. These holes served as markers, if you will. And these markers could be used to predict eclipses, at least according to Dr. Hawkins. And in his popular book, Stonehenge Decoded, he gave the world the idea that the monument was a Neolithic eclipse computer. This giant circular monument of stone may have been used, or it may have been the first computer to try to predict the future eclipses of both the sun and the moon. And as I said, the people who were able to calculate, who were able to interpret the movements of the sun, moon, planets in the sky were very, very powerful people. These soothsayers, these necromancers, these astrologers. And back then, 10, 1500 years ago, these people who were able to look up into the sky and make these predictions were very powerful. They would whisper in the ear of the king or the queen or the emperor, there's going to be some changes. The moon is going to disappear next week. So I mentioned cycles. Eventually, over time, man was able to deduce a specific cycle for eclipses of the sun and moon. That cycle was called the Saros cycle. It was derived from the Greek for repetition, eclipse circumstances that will recur at intervals of 18 years, 10 and a third, or 11 and a third days. It depends on how many leap years happen to intervene in that 18-year period. If 5 leap years intervene, 11 days. If 4 leap years intervene in that 18-year period, only 10. And I'll give you an example of how the Saros works. So here is a map of a solar eclipse that took place in 1963 on July the 20th. And that narrow blue band that you see there, that happens to be the path of the total eclipse. The moon's shadow first touched the Earth over northern Japan, over Hokkaido Island, then moved across the Pacific Ocean, crossed through Alaska, all the way down across central Canada, and then moved through the state of Maine before exiting out into the Atlantic Ocean and lifting off the surface of the Earth midway between the United States and Africa. So that eclipse was totaled on the 20th of July, 1963, and these other areas, these lines that you see here, is the zone of the partial eclipse. So you can see a total eclipse here, but the other region, this large zone here, was where at least the eclipse was going to be visible as a partial eclipse. These lines indicating how much of the sun would be covered. Right along this line here, that's the 25% line, so if you were in Los Angeles on that day, you would have seen a 25% partial eclipse. Here across this line, that's the 50% line. If you were in Miami, 50% of the sun was covered. This line was the 75% line across the mid-Atlantic, and again, across here, along this band, this blue band, that was a total eclipse of the sun. Now, if the Saros cycle works, then, and there was, over that span of 18 years, 5 leap years intervened. So what that means is that 18 years and 11 days later, so what's 18 to 1963? That's 1981. And what's 11 to July 20th? That's July 31st. So on July 31st, 1981, we should have a recurrence. The shadow of the moon should take basically the same track across the world 18 years and 11 days later. And it does. Take a look. Same type of totality path, same zone of partial eclipse. What's different though? There is something different, that it's not happening over North America. It's happening over Asia. Actually, it passed over Siberia and then moved down over the Pacific Ocean and came to an end, not in the middle of the Atlantic Ocean, but just to the north of the Hawaiian Islands. Remember what I said though. If the Saros cycle is 18 years, 11 and a third days, the Earth has rotated 1/3 of the way around, 120 degrees, and so when the shadows return to their spot, as was the case 18 years prior to that time, what we have is a completely different area of the globe that is experiencing a solar eclipse. But the Babylonians, the Chaldeans, the ancients figured this out 2,000 years ago. And you know, I'll bet you that if you tomorrow go outside, walk, along Main Street of your hometown, stop a couple of people and ask them, "Excuse me, sir," or "Ma'am, could you tell me how it is that the moon changes shape? Tell me what causes that? That sometimes I see the moon as a full phase and sometimes half or a crescent. How does that happen? What causes that?" I guarantee you, if you ask 10 people, 9 out of 10 would say, "I don't know. It's something to do with the Earth and the sun," or whatever. We in the 21st century, we know nothing, or most people, Joe Sixpack knows nothing about the movements of the sun, moon, and planets. And yet they're the same ones, by the way, who read the astrology in the newspaper. And yet, 2,000 years ago, we have people who were able to ferret out the movement of the shadow of the moon on the surface of the Earth. We're able to determine a cycle and predict the occurrence of solar and lunar eclipses. Oh, there was another cycle, by the way. That cycle is called the exoglemos, the triple Saros, or the turning of the wheel. If you take 3 Saros cycles, multiply 18 by 3, you'll come up with 54. And 11 days, you multiply that by 3, it's about just over a month. Now, I'm not going to ask you to remember the exoglemos. I'm not going to ask you to remember triple Saros, but I do want you, before this talk is over with, you're going to reference one number, 54. That's going to come into play in our talk about eclipses later in this particular presentation. Oh my goodness, what the heck is this? Looks like a hunk of junk. But believe it or not, what you're looking at right now is the very first example of an analog computer. This, believe it or not, was a computer called the Antikythia mechanism. And it is an ancient Greek hand-powered model of the solar system, described as the oldest known example of an analog computer used to predict astronomical positions and eclipses decades in advance. It was found among wreckage from a shipwreck off the Greek island of Antikythia in 1901. Its construction relied on theories of astronomy and mathematics developed again by those guys, the Greeks, sometime around 200 BC. So this thing, as best as we can tell, was made and designed sometime around the year 200 BC. Now in 2008, a team from a British university used computer X-ray tomography and high-resolution scanning to image the inside fragments of this crust-encased mechanism, read the very faintest inscription that covered the outer casing, and this suggests that it had originally 37 meshing bronze gears to calculate the positions of the 5 classical planets, follow the irregular orbit of the moon, the movement of the sun through the zodiac, as well as to predict eclipses. And what do you know? Those British scientists, from all of that, constructed a working model of what this probably was doing all those years ago. How unfortunate that this mechanism probably was lost on a ship sinking sometime before the Common Era, before the birth of Christ. How would science and astronomy would have advanced if we had still had this in our possession, or if the Greeks had it still in their possession long after they lost it in that shipwreck. But again, here's an example of predicting eclipses hundreds and thousands of years ago. The Antikythera mechanism. Amazing. We also have eclipses in history. And what is probably the most famous eclipse of ancient times ended a 5-year war between the Lydians and the Medes. These were two Middle Eastern armies that were locked in a fierce battle when suddenly the day was turned into night. And the sight of this total solar eclipse, which we now know occurred on May 28th, 585 BC, was startling enough to cause both nations to cease hostilities at once. Boy, wouldn't it be great if we could have that happen over the Ukraine? Oh, how great that would be. Well, that was 585 BC, though this was uncivilized man. Anyway, they agreed to a peace treaty and cemented the bond with a double marriage. That is probably the most famous solar eclipse in history. But we also have lunar eclipses that made history as well. You probably know who this guy is. You learned about him in grammar school. He sailed the ocean blue in 1492. Christopher Columbus. And Columbus not only sailed in 1492, he made 3 voyages to the New World, but the 3rd voyage, he almost met his end. It was in the year 1503, and he found himself stranded on the island of Jamaica. His ships were damaged and beyond repair. Now, at first, he and his crew were able to get food and water from the natives in exchange for baubles and trinkets. I'm sure the natives were very intrigued by, the strange metal and the way it could make a sound. And these little baubles, these tchotchkes, so to speak, helped get Columbus and his crew free water, and the natives gladly brought them free food. This is great. We'll just wait for the caravel, the rescue caravel to come, which Columbus at first thought would be most any day now, any time now. But as the days turned into weeks, and then as the weeks dragged into months, the Jamaicans finally refused to supply any more food or water to Columbus and his crew. And now Columbus's own crew were ready to turn against him. And faced with the prospect of both starvation and mutiny, the great Italian admiral conceived of an ingenious plan. And that plan involved his navigational tables. Columbus had them in his cabin, and in looking at it, he made a discovery. And that discovery was that there was going to be a total eclipse of the moon that would occur and commence when the moon rose above the horizon on the last night of February in the year 1504. He arranged a meeting with the natives just prior to sunset that evening and just prior to moonrise on the start of the eclipse. And he announced then that because he didn't like the way they were treating him and his crew, that the Almighty had decided to permanently remove the moon as a sign of his displeasure. And Columbus timed his theatrics precisely. No sooner had he proclaimed that the moon's disappearance, then as the moon appeared above the eastern horizon, there was a bite that was taken out from it. Oh dear. The natives were terrified, and as the moon gradually diminished, they pleaded with Columbus to restore it. They would provide him with anything that he wanted, all the food, all the water he wanted, but please, please bring back our wonderful bright moon. When the moon became totally eclipsed, Columbus told them that he would try to bring it back for them. You people are nice. You helped us out when we first landed here and giving us all the food and water and everything. You're a bunch of good guys. I'm going to tell you what I'm going to do. I'm going to go back into my quarters and I'm going to speak with my Almighty God and try to convince him. I will intercede on your behalf. I will try to convince him to bring the moon back. Now, I can't make any promises, but I will do my level best. And so Columbus went back into his quarters and he conferred with his God. You want to see what his God was? Any of you who ever saw the movie The Wizard of Oz know exactly what he used. An hourglass. His God was a simple hourglass which he used to time out the duration of totality. And a few minutes prior to the end of the total phase, he stepped back outside and announced that his God had pardoned them. And yes, he would allow the moon to return to its place in the sky. And sure enough, it did. Well, Columbus had no more problem with the Jamaicans, who gratefully supplied him and his men with all the food and all the supplies they needed, until finally that rescue caravel arrived from Europe to take them all home. Now, this is a very famous historical story, read by many, many people, both known and not so well known, but probably one person who took full advantage of it was this guy, Mark Twain. Mark Twain, as you know, was very famous for writing a number of stories, most famous of all, Tom Sawyer and Huckleberry Finn, but he also wrote probably one of the great eclipse stories of all time, from 1889, A Connecticut Yankee in King Arthur's Court. The book was made into one of the very first talkies, one of the very first movies, way back in the year 1931, and the legendary humorist Will Rogers played the part of a 20th century Yankee who had been sent back in time to the days of King Arthur. He's about to be burned at the stake as a sorcerer, but he has one last hope. Looking at a little black book he carries, he's discovered there will be a total eclipse of the sun at high noon. And Will Rogers convinces King Arthur that if he doesn't get what he wants, being removed from the stake, that he was going to take away the sun.
Hey, King, you better turn us loose right away, because if you don't, I'm sure going to put the old Yankee curse on you. All right, King, you asked for it. Now you're going to get it. Prosperity, farm relief, freedom for Ireland, and light wines and beer. And I'll see what I can do for you. But I'll do the best I can. Cody, Hoover, Rockney, and Al Smith. Witnessed the greatest of miracles. All homage to him who hath brought back the sun.
Hip, hip, hooray. The whole thing about eclipses boils down to just one single thing: shadows. Shadows. And all you need to do, how many of you remember Robert Louis Stevenson's little poem, My Little Shadow? I have a little shadow that goes in and out with me. And what could be the use of him is more than I can see. But sometimes the shadow that we speak of plays a role in the predictions of eclipses. And sometimes a shadow will come along to eclipse the sun unexpectedly. Here's something that happened several years ago during a baseball playoff game during the postseason between the Washington Nationals and the San Francisco Giants at Pac-Bell Park in San Francisco. Watch what happens as it's the top of the first inning as the game is just getting underway.
Be a big pitch for Madison.
And with a strange shadow being cast mid-pitch as a result of a blimp or a plane flying overhead. It's 2 balls and a strike to LaRoche. Even Adam had to look up and say, what is going on here?
And that would be the blimp. The lights went out. No clouds. Beautiful sunny day.
It's hard enough to hit Madison Bumgarner.
Yes, there was an eclipse of the sun, at least for some of the ball players who were out on the field, who were underneath that shadow of the blimp. But now I'm going to show you another picture, very similar and yet dissimilar to what we have just seen. And that picture was taken not from a baseball field, from 250 miles up above the Earth's surface from the now defunct space station Mir, looking down on Europe August of 1999, and that big blotch is not the shadow of a blimp, but it is the shadow of the moon. And, you know, you heard that announcer in the play-by-play saying, the lights went out. Well, here, anyone who happened to be underneath that big dark blotch, the lights indeed went out. There was a total eclipse of the sun that occurred over Europe. And again, this no different than what you just saw on the baseball field, a shadow. A shadow is what is the main cause of these events. Before we get into eclipses of the sun, let's very quickly touch upon eclipses of the moon, shall we? Eclipses of the moon, now we all know that the moon does not shine on its own. It relies upon the sun. Sunlight reflecting off of the surface of the moon, as seen here on Earth, we see that big beautiful orb in the sky. And if we were to deprive the moon of that sunlight, it would disappear, right? We would have a complete vanishing of the moon. But yet, when the moon completely moves into the shadow of the Earth, it doesn't disappear. Instead, during the total phase, it lights up like a coppery red or orange ball. And why is that? Why does it suddenly light up like that? Well, it's because if you've ever taken atmospheric science, such as I did, in order to graduate, one of the things we had to learn about was something called Rayleigh scattering. You have a kid coming up to you, and if you're a parent, and little boy or little girl comes up, Mommy, Daddy, why is the sky blue? Well, it's blue, and you have to figure out a way not to confuse the kid. But sunlight, of course, is composed of all colors of the rainbow. So when we have the sun high into the sky, the sun's rays are taking a rather short path to get to our eyes. Short wavelengths of light, which are tipped or tilted toward the blue end of the spectrum. So we have a blue sky when the sun is high. But when the sun is low in the sky near the horizon, those light waves are taking a much longer path toward us. And as a result, that tilts more toward the yellows, the oranges, and the reds. And so when the sun comes up, or when the sun is going down, and sometimes even when the moon is going up and down near the horizon, we see that beautiful orange or red coloration. Well, when we are on the moon and looking up at the sky and looking at the time when there's an eclipse of the moon for us here on the Earth, what the people on the moon, if there were any, astronauts who might be walking around on the moon, looking up at the sky at that time, they would be seeing an eclipse of the sun. Because during a lunar eclipse, the Earth comes between the sun and the moon. And the Earth, being 4 times bigger than the moon, covers not only just the disk of the sun, but everything. The prominences, the beautiful corona. But when we have totality, what we have is a black disk, and it is surrounded by a thin red ring of light. That's the red ring that we see near the horizon at sunrise and sunset. So basically, during the total phase of a lunar eclipse, we are seeing the light from all of the sunrises and all of the sunsets occurring at that moment in time, filtering through the atmosphere of the Earth into the shadow of the moon, into the shadow of the Earth, I should say, and onto the moon, and lighting up the moon at totality in that unusual orange or red coloration. And by the way, after we are done with our solar eclipse this year, put this in the back of your mind, March 14th of next year, March 14th, 2025, we are going to be treated to a total eclipse of the moon. And everybody, in not just North America, but South America, will be able to see it as well. The Earth, the Western Hemisphere, will be turned toward the moon at the time of the eclipse. That's the great part about a lunar eclipse. There's no restrictions. Wherever the moon is above the horizon when the eclipse is occurring, that will be the region that will see the eclipse. And in this case, for totality, weather permitting, over 1 billion people in North and South America will be able to look and see and enjoy that lunar eclipse again next year on March 14th. Now, as far as the solar eclipses are concerned, you ever notice that when you look up into the sky, the sun and the moon are pretty much the same size? And how can that be? You know that the sun is much larger than the moon. The sun is 93 million miles away from the Earth, and the moon is, well, 2,100 miles across or thereabouts. The sun is nearly 1 million miles wide. The sun is 400 times bigger than the moon. But while the sun is 93 million miles away, the moon is only about 250,000 miles away. It's 400 times closer. So there's a bit of a compensation there. The moon's closeness to the Earth compensates for the overly large size of the sun, so both objects appear the same size in our sky. Well, not exactly the same size. You see, the moon goes around the Earth in an elliptical orbit. And there are times when the moon is rather close to the Earth, what we call perigee. At those times, the moon is 221,000 miles from the Earth. And then on the other side of its orbit, the moon is far from the Earth, apogee, 253,000 miles away. There is a variation in the distance between close and far point of about 12%. And indeed, that also causes the size of the moon to vary by about 12 or 13%. On the left, you see a full moon at apogee, far from the Earth. And on the right, you see a full moon at perigee, close to the Earth, and the news media. Oh, don't we love the mainstream media? In the last 10 or 12 years, they've come up with all kinds of brandings. For lunar eclipses, blood moon. And for storms that blow up off the mid-Atlantic coast, bomb cyclone. And most recently of all, atmospheric river. And for this case, when the moon is close to the Earth at full phase, we now have in our lexicon, super moon. And that's what happens when the moon is close to the Earth. We have supposedly or purportedly a super moon in our sky. When we get the alignment properly set up, when the moon, the sun, and the Earth are in such an alignment so that the shadow of the moon falls on the surface of the Earth, if it happens at the time when it's near apogee, when it's far from the Earth, what happens? That dark cone, which is where you would look to get the sun completely covered, it stretches out to a point and doesn't quite reach the Earth. Not quite. It's too far away to touch the Earth. So what would you see if you were where that red dot is? You would see this. You would see the moon covering the sun, but covering it in such a way so that it would leave around it a ring of sunlight. An annular, not an annual, but an annular eclipse. Annular from the Latin phrase annulus, ring-shaped. And again, here's another one of those brandings that have come up in recent years. The mainstream media, instead of calling it an annular eclipse, they now call this a ring of fire in the sky. A ring of fire eclipse. You know what I call it? The penny on nickel eclipse. Pretend that the sun is the nickel and the moon is the penny. Now, try as you might, no matter what you do, you're never going to be able to cover all of that nickel with the penny. And that's just what happens during an annular eclipse. The penny or the moon lines up precisely, but still leaves around its edges a ring of sunlight in the sky. You may remember, just this past fall in October, we had a ring of fire solar eclipse, which stretched down across that dark, narrow band that you see there. Anywhere within that narrow band, which was about 130 miles wide, you could see the proper alignment and see the ring of fire in the sky. If you were anywhere else in the United States, you'd still see an eclipse, but it would be only a partial. But everybody wanted to get inside that band to see the ring of fire. In fact, things got so out of hand that on many roadways, they had to put up on those electric signs, major delays. Expect major delays if you're headed for the eclipse track on Saturday, October 14th for the solar eclipse. You may remember that here in New York on that day, of course, it rained. So we saw none of it. What we had to do, if we wanted to see any of it, was tune in on our televisions. The Weather Channel did wall-to-wall live coverage of the eclipse that day. They had all of their various weathercasters outside in various places along the eclipse track. Jim Cantori, who always gets excited about anything at the drop of a pin. I remember watching Cantori, and when they got to the ring phase, he's saying, "Oh my goodness, look at that! Look at that! It's the most amazing thing I've ever seen! That's crazy, that's wild, that's awesome, There's no difference. It's like night and day when you compare the ring of fire to a total solar eclipse. And I can hardly wait. I'm hoping that Cantori is covering the total eclipse for the Weather Channel, because I can hardly wait to see what he's going to do when he experiences totality on April the 8th. Of course, totality is when that shadow does manage to make it to the Earth. On October of last year, for the eclipse, the annular eclipse, we had the moon about 250,000 miles away. This time around, in April, the moon is going to be 25,000 miles closer. The shadow is going to make its way down to the surface of the Earth. It will touch the Earth, and anywhere within that shadow cone, you will be able to see a total solar eclipse. Now, some of you of a certain age may remember this. Sunday, March 8, 1970, this was the front page of the New York Times. The day before, there was a wonderful total solar eclipse that went across the southeastern states and then went up along the eastern seaboard. And here in New York, we just missed out on totality. We had 96% of totality. Millions watched eclipse in clear sky, and during the maximum phase of the eclipse, when 96% was covered in New York, an eerie twilight fell briefly over the region. That was March 7th, 1970. Wait a minute, hold on. Now you remember I asked you earlier to remember one of those cycles, the Eclipse. What was the number I asked you to remember? What was that number?
54.
54! And 32 days plus or minus 1 day. Well, let's see. March 7th, 1970. If we add 54 years to that, that's 2024. Hey, that's this year. And March the 7th. Let's add 31 days to that. That brings us to April 8th. April 8th, 2024. Oh, we may have a very significant eclipse coming our way. Here's the eclipse in 1970. And as you can see, the path of the total eclipse in 1970 started in the Pacific Ocean, ran across Mexico, across the Gulf of Mexico, northern Florida, southeastern U.S. Look how we missed totality. We just missed it by about 80 miles. Then it continued north, passed across Nantucket in Massachusetts, Nova Scotia, Newfoundland, and then finished out to sea in the middle of the Atlantic Ocean. That's 1970. Look what happens when we factor in the Eclipse, the 54-year cycle. Boom! An eclipse that is very, very similar. Remember, the Eclipse is the turning of the wheel. 3 cycles and the shadows come back to the same part of the globe. And look, not quite the same, but actually better for us this go-around. Because now, again, across Mexico, but this time moving through Texas and up into the Tennessee and Ohio River Valley, eastern Great Lakes, upstate New York, northern New England, and across Atlantic Canada. My goodness, what an eclipse of the sun this is going to be for us here in the eastern part of North America. Here's an animation that shows you the shadows as they interact with the Earth. The large shadow is the penumbra. From that large shadow, that's where you'll see a partial eclipse. But that small circular black area, that black dot, we'll rerun it again. Anybody in the path of that dark shadow will see the great show of a total eclipse of the sun. And that dark shadow path, and here's a different view. Take a look down here. Look at this. This is going to give you an idea of how many minutes the totality is going to last. Notice as the shadow moves onto the Earth, 2.5 minutes. But then as we get near the middle part of the eclipse track, 4 minutes, 28 seconds. Then it diminishes as it begins to move over the United States. But look, 4 minutes and 10 seconds, 4 minutes, 3 minutes and 58 seconds. That's still a fairly long totality. I must tell you that I did a study and wrote an article about it for space.com. In the last 100 years, there have been 14 total eclipses over the United States. And the average duration of totality of those 14 U.S. eclipses was just over 2 minutes. Here we're talking about 4 minutes plus. This certainly is going to be the eclipse of the century, at least for the United States, and one that is certainly not to be missed. I told you it's going to be visible from Texas. It's going to be visible from 15 states, and one of those states is right here in little old New York. And believe you me, Governor Hochul and her various supernumeraries who run the I Love New York campaign are telling people, come for the eclipse, stay for New York. The eclipse will move across western and northern New York State, and everybody is hoping, of course, that it's going to be something that will be available to us, weather conditions permitting. Now consider this, if you will. Some people travel, scientists, astronomers, travel halfway around the world to position themselves to get into the path of the total eclipse. They spend a lot of time, a lot of effort, a lot of money to get into that shadow, to see 2, 3, 4, 5 minutes of totality. Look what all of you have staring before you now. You have, where are we? We're here in beautiful Rockland County, Suffern, right here, right about there. Get in your car that morning at the crack of dawn, get in your car and travel up Interstate 87. Go past Albany, Saratoga Springs, past the town of Shroon Lake, and suddenly, in the Adirondack zone, you're in totality. How many hours is that? 3, 4 hour drive? Is it worth 3 or 4 hours to see something that you may have never seen in your lifetime? And look at the cities that are going to be involved. Erie, Pennsylvania, Buffalo, Rochester, Syracuse, Watertown, New York, across the border in Canada, Kingston, poor Toronto, they just barely miss out. Hamilton, Ontario, Cleveland, the mistake by the lake, as it's called. But look at this. We have a total eclipse that is literally coming to us for a change. And you should not pass on this. It is an amazing sight. Now, if you stay here in the New York metropolitan area, this is what you're going to see. You're going to see a partial eclipse of the sun. You're going to see about 91% of the sun covered at 3:25 that afternoon. And you say to yourself, oh, Joe, 91%, that's quite an eclipse. I think I'll stay here. I think it seems worth it to see that much of it. Well, let me tell you something. The best that you're going to get out of this is if you have a clear day. It's going to get about as dark as one of those cloudy, dreary days we've had lately here. No big deal. That's about it. It will get a little dark, but it's not going to be anything to write home about, but that's what you're going to see here in the New York metropolitan area. Again, I urge you, stress to you, beg you to make an effort to go and see the total eclipse, because it is the total eclipse that is so phenomenal. The moon appears to move slowly between us and the sun. At first there appears to be just a small bite out of one side of the sun. Then the bite grows larger and larger. The sky begins to dim, and you begin to understand why these moments were so terrifying to early man. Now the time approaches when only a blinding crescent appears in the sky. Then the sun shines only through the craters and mountains of the moon. And then the cosmic vision of a lifetime, a total eclipse of the sun. Only the outer atmosphere of the sun is visible now. The incredible corona flashes out into view. Even the stodgiest of astronomers who have experienced this moment of total eclipse speak of it in awe. On that second Monday in April, tens of millions of people will get a rare chance to see it for themselves. But then, after about 4 minutes or so, the cosmic sequence will reverse itself, the sun flashing back into our sights. The total eclipse is over, and unless they plan to do some long-distance traveling, most people will probably never get another chance to see one again. Terrible. So, I stress to you, try to see an eclipse. There's so many things that happen leading up, in the moments leading up to totality and during totality. For example, you probably have all seen, when you've looked up into the sky, stars twinkling. Twinkle, twinkle, little star, how I wonder what you are. Well, the stars aren't twinkling. The beam of light that's coming from the star is passing through our turbulent atmosphere with pockets of moving warm and cold air, and that turbulence causes the star to twinkle. Now, the sun is a star. Have you ever seen the sun twinkle? No, of course not. The sun doesn't twinkle. But when we narrow that sun down to a filament of light, in the minute or two before totality, that thin filament of light interacting with that turbulent atmosphere causes shadow bands, waves of shadows, light and dark, that traverse and pass over the ground and on the sides of homes. Really weird. Some people, and again, for years I always referred to them as shadow bands. Now, as of the result of the last eclipse in 2017, they're not called shadow bands anymore. They're called shadow snakes. But snakes, bands, whatever, you only see them for a minute or two just before totality and just after totality. A very strange and weird effect. And the diamond ring, the beautiful diamond ring, when the last little bit of the sun shines between mountains and valleys on the moon in that big, beautiful globe of light, vanishing, interacting with the innermost corona, which is now beginning to appear as totality begins. Oh, diamond ring effect. And look at what you see during totality. Beautiful colors. I'm sure all of you saw beautiful sunrises and sunsets. We had a beautiful sunset tonight. I don't know if any of you had a chance to see it. What a magnificent view. But as beautiful, as magnificent as that was, it will pale in comparison to the colors that will be visible to you. This was taken by a friend of mine during the mid-totality stage of an eclipse in Montana back in 1979. A gorgeous effect. The sky at totality gets about as dark as it does about 30 or 40 minutes after sunset or 30 to 40 minutes before sunrise. And in fact, during this upcoming eclipse, if you're up and out and looking, you'll see near to the corona of the sun, to the lower right of the sun, 15 degrees from it, anyway, you make a fist, right? And hold it out at arm's length. Your fist is equal to 10 degrees. So roughly a fist and a half away from the sun in that nighttime or semi-darkness sky will be the brilliant planet Venus. And 30 degrees, 3 fists away to the upper left of the sun, will shine the planet Jupiter, and a scattering of other bright stars of the first magnitude. So the stars come out during totality. You don't see that if you stick around here in Suffern on eclipse day with 91% coverage. You've got to see totality and the beautiful corona. Oh, a great crown. The corona of the sun. Beautiful, beautiful sight. Streamers, ragged at the edge, streaks running through it. The corona, the outer atmosphere of the sun, and also near to the disk of the darkened disk of the moon, you might be able to see a few bright prominences, hydrogen tongues of gas lifting off the surface of the sun. And we are right now near solar maximum. So that means that the corona may be larger than usual, brighter than usual, and you may be seeing more than a few of those red or electric print prominences around the disk of the sun. And did you know that this gentleman, Albert Einstein, became famous thanks to a solar eclipse? Albert Einstein owes his fame to a total eclipse of the sun. How is that possible? It's possible because classical Newtonian physics says that a beam of light will travel out into space in a straight line, unimpeded by nothing. It'll just go out in a straight line. But according to Albert Einstein, relativistic physics says that if there's a large enough object, a massive enough object with a large gravitational pull, that if that beam of light passes by that particular object, that object will bend or distort that light in another direction. And that's exactly what was proven at the solar eclipse in 1919. And after it was proven, after it was shown that that was the case, as you can see in this New York Times article, men of science more or less agog at the results of eclipse observations. Einstein's theory triumphs. Stars were not where they seemed or were calculated to be, but nobody need worry. And indeed, at the 1919 eclipse, an experiment was created. Actually, it was not at the eclipse itself. 6 months before the eclipse, a photograph was taken of the sky, that part of the sky, where the sun was going to be during the eclipse 6 months later. And after the photograph was taken, all the stars that were in that area were carefully and precisely calculated. Their positions were carefully and precisely calculated so that we knew exactly where they were and where they should be when the eclipse were to occur 6 months later. And then, when the eclipse took place, what happened? As it says here, the theory of relativity suggests that the sun's gravity bends the path of light from distant stars. A testable prediction, but only during a total eclipse of the sun. And the eclipse of 1919 fit that bill very, very nicely. When they looked at the positions of the stars that they took a photograph of 6 months earlier, the stars had shifted in their positions. Those were the stars near to the disk of the sun. And how could that be? I mean, they had calculated and had measured precisely, and now the stars were no longer where they were supposed to be. They were shifted by the gravitation of the sun, the light of the sun, bending or shifting that light, just as Albert Einstein's theory of relativity had predicted. So Einstein owns his fame indeed to a total eclipse of the sun. It was the astronomer Arthur Eddington who took the photographs that proved Einstein's theory correct in 1919. So I hope that Einstein treated Eddington to a nice drink after the eclipse was over. And now we get to the liability part of our program, and that is looking at a total eclipse, looking at an eclipse in general, a solar eclipse. You know, it's a funny thing. Most people probably think when they hear about an eclipse, oh, we can't look at it. We can't look at the sun because it's the eclipse that's causing us not to look at the sun. It's the eclipse that's making it dangerous to look at the sun. It's not. The sun is dangerous all the time. It's just that when we have an eclipse, suddenly people who don't normally stare at the sun say, oh, an eclipse! And they stare at the sun. And some people, like this dummy here, get his telescope out, and believe it or not, Galileo did that. Galileo, with his crude telescope, pointed it at the sun and actually burned his eyes. He eventually recovered his sight, but for about a week he couldn't see very well in the eye that was burnt by the sun. And one of the other funny things, a phone call to the Hayden Planetarium some years back, and I know this for a fact because I was the guy who took the phone call for the planetarium. This was on the day before an eclipse of the sun was going to happen over New York, a partial eclipse. And I said yes. He said, can you tell me something about tomorrow's eclipse? I said, yes, what would you like to know? He said, can you tell me when the eclipse is going to end? I said, okay, let me just check here. The eclipse will end at 2:54 tomorrow afternoon. Let me write that down. 2:54. So the eclipse is going to be over with by 2:54. And I said, yes, sir, it will. He said, okay, so that means I can look at the sun after that, right? No. No! Oh, my goodness. And unfortunately, there are a lot of people who probably think that, who probably believe that. If you have a telescope, this is the way to do it. You point your telescope at the sun, you don't look through the eyepiece, of course, and make a kind of a shade collar near the front of the telescope, and then project the image of the sun onto a paper or card. It'll not only give you a magnified image of the sun, but it'll give you an image that not just you, but everybody around you can enjoy. Here's an example. Here's a gentleman, he had his telescope, made the shade collar, pointed it toward a screen, and there's a beautiful, perfect enlarged image of the eclipse of the sun that many people around him were able to enjoy. Don't have a telescope, have binoculars? Use binoculars. Here's this young lady who is projecting the image of the sun through her binoculars, doing the same thing, and there you see the image of the sun and a little tiny bite on the bottom of each of the images created by the binocular image. Lots of kids like to make their own eclipse projector using a cardboard box. You cut a hole in one side of the box, cover it up with aluminum foil, poke a pinhole through the aluminum foil, and then allow the sunlight to shine through the pinhole and onto a white paper typed to the inside opposite end of the box. And the kids love it. They put the box over, they're able to observe the eclipse. Some people don't use a box. This young boy here next to the kid using the box, using, again, just a couple of pieces of paper with a pinhole in it. What a great way to watch an eclipse. And if you don't have a box, if you don't have a telescope, you don't have binoculars, you've got a tree. A tree, those little tiny images, those little spaces in between the leaves during the eclipse, they'll shine through the spaces and they will be projected onto the ground, and you'll be able to see not just one or two, but literally dozens or hundreds of images of the sun. My wife and I went to South Carolina in 1984 to see an eclipse of the sun, an annular or ring eclipse. And the place we were at was a middle school in South Carolina, in Greenville, and surrounded by beautiful shade trees. And the thing that amazed us was not just being able to see this, I wish I had a movie to show you, because the trees were going back and forth, and the leaves, of course, were going back and forth, and so the crescents were shining in and out. It was almost like they were twinkling in a way. And I said to myself, this is neat. I'd rather look at this and look at the sun through a pinhole or a telescope. This is an amazing, amazing sight. If you don't have a tree, And if you don't have a box, or a telescope, or binocular, you got a cracker? How about a saltine cracker or a Ritz cracker? Pull it out, there you go. There's your little projection images of the, not just one, but several images of the eclipsed sun. You got a mirror. You ladies with a compact or whatever, or just a small mirror, you're able to get the sun to shine onto the mirror and shine that image, 30, 40, 50 feet away onto a screen. There you go. I call that the pinhole mirror effect. And that's another way that you can safely watch and observe an eclipse using a pinhole. Of course, very popular nowadays in recent years are the eclipse glasses. And I will tell you now, if you don't have a pair of glasses, I would tell you right now, tomorrow, first thing, go on your computer, go on Amazon, order glasses, because they are going fast and furious. Just a few weeks ago, the American Astronomical Society had 15,000 glasses and put an announcement out and said, libraries, civic groups, anybody who wants an eclipse glass or glasses, write to us, email us, we will send you glasses for free. And within less than a week, 15,000 glasses were gone. And they're still getting requests, even though they don't have any more glasses. Now, these glasses probably don't cost more than $2 or $3. And you can get like a 4-pack for $12. Very easy. They are special glasses because not only do they knock out the visible light of the sun, and I know some people, they say, oh, I've got sunglasses. Oh, my sunglasses, they're really dark. I can look at the sun through my sunglasses. And sure enough, if you look at the sun with the sunglasses, the sunlight is indeed diminished. And it does look like you can get a good view of the sun. But what the sunglasses are not doing is they are not preventing the infrared and the ultraviolet rays of the sun, the invisible radiations from the sun, to go right through those glasses. And over a span of maybe a minute or two, the retina of your eyes are being burned without you immediately being aware of it. You'll become aware of it later on when you're looking around. Hey, what are those dark spots that I'm seeing there? And they don't go away. That's it. You're done. So you can't use regular sunglasses. The infrared rays, that's the radiation that interacts with the blacktop of your driveway to melt the snow. The ultraviolet rays, that's what gives you a sunburn after 10 or 15 minutes. Do you want that to be hitting the retina of your eyes? No. So you need glasses like this. These glasses reflect not only the visible light, but the infrared and the ultraviolet. They use a special plastic called polymer, which effectively reduces both the visible and the ultraviolet infrared light so that you can look at the sun safely with these glasses. But again, if you decide to put in your order for these glasses, let's say a week or 10 days before the eclipse, you're likely going to get an email back saying, sorry, sold out, you'll get your glasses after the eclipse. You've been warned. And about 60 years ago, there was an eclipse of the sun, and Charles Schulz, the guy who created Peanuts, decided that he would write an arc, a story arc, over a week of the Peanuts characters getting ready to watch that particular eclipse. And Linus, the voice of reason in the Peanuts comic strip, he was the one that was telling all the other characters the proper way to watch the eclipse. And you can see here, he tells Charlie Brown, sunglasses, smoke glass, photographic negatives, even welder's glasses are not safe for directly viewing an eclipse. Well, he's right on 3 of the 4 cases. If you want to use welder's glass, yes, you can use welder's glass, but make sure that you're using the right kind. Welder's glasses come in various shades. There are shades that go by various numbers, and the only one that you should be using in those welder's glasses or goggles is shade number 13. If you use anything lower than number 13, the sun will be too bright and will be too dangerous to look at. If you use anything higher than 13, the sun will be much, much dimmer and not all that pleasing to look at because it's, again, so much dimmer to see. 13 gives you a perfect view of the sun. And the reason why the font is in green is that when you look at the sun through welder's glass, you get a green sun. So that would make the eclipse even more interesting to watch it and see a green sun in the sky. This is the thing that I wanted to really ring. If he was still alive, I'd get very upset with Charles Schulz, and I would tell him to his face, there is no safe method for looking directly at an eclipse, and it is especially dangerous when it's a total eclipse. Wrong, wrong, wrong. Because when the sun is in total eclipse, that's the only time that you should take off your glasses, throw away your pinhole cameras, your mirrors, and look up at that sun. That's the only time during those moments of totality that you can look directly at the sun. There is no danger to look at the sun during the total phase of the eclipse. And if you have binoculars or if you have a telescope, that's the time to look at it. But as soon as the sun begins to emerge, shields and filters and glasses back on. But people think that that is the worst time to look at the sun, is during totality. And again, so sad. I mean, there were people, a friend of mine who used to write for Sky and Telescope, he passed on some years ago, George Lovey. And George told me that he went to Virginia Beach to see a total eclipse in 1970. And people were all excited, looking at the sun through their glasses. And then 2 or 3 minutes before totality, what did those people do? Everybody fled into their hotel rooms and went inside during the total eclipse. Where are you going? The best part is coming. Oh, but it's total. We can't be outside when it's total. There are people who actually believe that. How sad. And other people think, well, let's watch it on television. Charles Kuralt, the late great Charles Kuralt at CBS News, when CBS covered a total eclipse of the sun back in 1970, he opened his program by saying, it's good that you're all here watching this show, because this is going to be the best way and the best place to watch the upcoming total eclipse of the sun. I tell you. And people probably, those people who were in Virginia Beach, they probably went inside to watch Charles Kuralt during totality. I tell you. And some people even feel this way about it, I guess. Don't laugh. The very first eclipse of the sun ever transmitted on television was a partial eclipse in 1951. They put a TV camera on the top of the RCA building, and during the Howdy Doody show, Buffalo Bob held stopped the proceedings with Clarabelle and all the other characters and said, a very special thing is happening now, an eclipse of the sun. And they actually showed the eclipse during the Howdy Doody show. And one gentleman who wrote about the history of the Howdy Doody show, the name of the book is, Hey Kids, What Time Is It? He said that his mother dragged him away from the TV because she didn't want him to go blind by looking at the TV during the eclipse. So there you go. Charlie Brown, of course, after hearing about all this, said, how would your ophthalmologist feel if I closed my curtains and stayed in bed all day? Oh. Well, I'm going to finish this talk now with 3 quotes about totality. One quote from the 19th century, one from the 20th century, and one from the 21st century. Quote number 1 comes from a British astronomer who, after experiencing totality for the very first time in 1851, British astronomer Edwin Duncan spoke for most of us who have seen a total eclipse when he declared, few can imagine how much I longed for another minute, for what I had just witnessed seemed very much like a dream. And the late Leif Robinson, a very good friend, former editor-in-chief of Sky and Telescope from 1980 to 2000, stated it more simply and succinctly. He said, no one should pass through their life without seeing a total solar eclipse. And finally, for the 21st century quote, I am using a good friend of mine, a very good friend. In fact, one of my longest and dearest friends who I've known for over half a century. His name is Glenn Schneider. He and I grew up together in the Bronx. We knew each other from high school. Glenn is truly an umbrophile. He has seen 35 total solar eclipses. His very first was in 1970, and he was so taken aback by what he saw. Even though he had binoculars around his neck, he didn't even use the binoculars. He was so mesmerized by the sights that were occurring in the sky and around him during that 2 minutes and 55 seconds of total eclipse. And it was Glenn who has since written about total eclipses. He wrote, if you want to experience the ultimate in human emotion, curiosity, and imagination, then see a total eclipse of the sun. Even if you are poor, starving, in hock, in trouble with the law, unbalanced, and totally addicted. See it anyway. It's worth it. I wish upon all of you who either will go venturing into and basking in the shadow of the moon for totality on April the 8th, 45 short days from now. Good luck, and even for those of you who will stay outside the eclipse track to see a large partial eclipse, good luck to all, and especially, with our fingers crossed, a clear sky. Thank you.